Alright guys, this is technically the second video for practice quiz 6.3, 6.4. So this is video part 2, I guess. And on this section we are analyzing radical equations and simplifying radical expressions. Okay, so we're going to be looking at radical equations and answering some true and false questions. We're also going to be simplifying square roots, cube roots, and other types of roots. On this question, it says, select all true statements about the radical equation y equals -2 square root of x plus 5 plus 1. Okay, let's begin by truly understanding this. The a value is -2. That means that the parent graph got reflected over the x-axis, got vertically stretched by 2, and the endpoint that used to be 0, 0 on the parent graph got shifted to -5, positive 1. So we might as well do a quick sketch so we could have some type of visual. So once again, the h value and the k value are the most important points. It's the beginning point. Think opposite of what you see right here, so -5, positive 1. So when you go -5 on the x, 1, 2, 3, 4, 5, and positive 1 on the y, we will have a beginning point right here. Okay. Now, before even drawing our graph that begins right here, let's go back to the parent graph. Okay, the parent graph is y equals the square root of x, and if you did think about the inputs and outputs of a parent graph, the square root of 0 is 0, the square root of 1 is 1, the square root of 2 you don't want to do because that's a crazy decimal, square root of 3 also crazy decimal, square root of 4 is 2. So we have the coordinates 0, 0, 1, 1, and 4, 2. Let me actually plot those points here. 0, 0, here's 1, 1, here's 4, 2. So it does start here at 0, 0, and it shoots off in this direction, going forever up and to the right. And that is, the parent graph is obviously only in quadrant 1. I mean, yeah, it starts at 0, 0, which is in between all quadrants, but it is all in quadrant 1. It doesn't go ever into quadrant 2, 3, or 4. Now, again, this one, it gets reflected over the x-axis. So imagine that. Instead of opening up, it gets reflected and opens down. Not only that, it gets vertically stretched by 2. So instead of, like, let's say I did reflect it over the x-axis. That means that this yellow dot right here reflected over the x-axis would be down here. This one up here would be down there. I'm not even going to draw it though. But this a value on the parent graph, the a value on the parent graph is 1. So that's why the square root of 1 is 1. Okay, the square root of 1 is 1. But when you think about if it gets vertically stretched, if you put a 2 right here, yeah, it would be the square root of 1 is 1, but times 2 would make it 2. So it would be up 2 over 1. That would be a vertical stretch of 2. So over here, it gets vertically stretched by 2, so it'd have to go down 2 over 1, if that makes sense. So I'm just going to, like I said, it is a sketch. So down 2 over 1. We're going to draw this sketch, and it goes off in this direction forever. Okay, so let's begin reading these true statements. Well, if they are true or not. This graph will never touch quadrant 1. This from here goes down and forever to the right and to the bottom. So it crosses through, it starts in quadrant 2, crosses through quadrant 3, and it goes forever into quadrant 4. It never crosses quadrant 1, so it will never touch quadrant 1. That is absolutely true. That's why there's a green selection right there. The domain is x is greater than or equal to -5. Okay, so again, if we go to our sketch, that beginning point is -5, positive 1. The x value is -5, and from on the x-axis, on the x number line, does it exist to the left of -5, which would be less than or equal to -5, or to the right of -5, which is greater than or equal to -5? The domain is greater than or equal to -5, okay, because it does go to the right forever. Even though it goes down, it continues to go to the right forever. That's right. I said right instead of right. Anyway, so this is true also. The domain is greater than, x is greater than or equal to -5. The graph will pass through the coordinate 4, -5. Okay, well, if I look at the coordinate 1, 2, 3, 4, and I go down to -5, I mean, maybe, but I can't accurately answer that here with this graph. So technically you could graph this on Desmos, but it's even easier to just think of what a coordinate really is. A coordinate is x and y, which is an input and an output. So what this coordinate is saying, by me asking you, does this pass through this coordinate? I'm really saying, if you plug in the x value of 4, will you get out the y value of -5? And let's figure that out. If I did plug in a 4 right here into the x, what is 4 plus 5? It is 9. And what is the square root of 9? Square root of 9 is 3. And what is 3 times -2? That's -6. And what is -6 plus 1? That is the output -5. So that is a true statement, as you can see. It's a green dot right there. The range of your y values, it's up and down, and we are talking about this red graph. The y values, the beginning point, the most important point, HK, the y value is 1, and does this graph exist above the y value of 1, which would be like y is greater than or equal to 1, or below 1, which is y is less than or equal to 1? Obviously, it's y is less than or equal to 1, so that's also a true statement. Last but not least, the parent graph gets reflected over the x-axis and has a vertical stretch of a factor of 2, and also shifts 5 to the right and 1 up. So we did say that it does get reflected over the x-axis. It does get vertically stretched by a factor of 2, right? Reflected over the x-axis, vertically stretched by a factor of 2, but it does not shift 5 to the right. You might make the mistake of thinking that because you see a +5, but remember, think opposite on h. So that's really a -5, right? That's where it shifts to. It shifts -5, or 5 to the left and 1 up. So this word right here, 5 to the right, that makes it false. And that is why we have a red check right there. Let's move on. Select all true statements about this guy. Once again, it gets reflected over the x-axis. It doesn't get vertically stretched or compressed because there's no fraction or number in front. It does get shifted 2 to the right because you think opposite on h. H is +2, k is +8, so it gets shifted 8 up. Let's start just reading through this. This graph only exists in quadrant 1 on the XY plane. Well, you could graph it on Desmos to see that, or you could sketch it. I'm going to sketch it, and that is probably the world's ugliest XY plane right there. But anyway, let's identify our H, which is +2, and our K, which is 8. This is the most important point, 2, 8, which is way up here, okay, way up there. Now, I do know that it's reflected over the x-axis. So again, originally, the y equals square root of x parent graph, y equals square root of x parent graph, it was right there, and it shoots off in this direction, forever going up and to the right. But this negative as -1 as the a value causes it to reflect and shoot this way. So this guy that got shifted 2 to the right and 8 up is going to go in that direction, going down and to the right forever. Okay, like that. That's just a sketch. You could graph this on Desmos so you could see it. It'll be way up here at 8, +2, 8, and then it shoots down and to the right forever. Okay, so this graph only exists in quadrant 1. Here's quadrant 1. Is that true? Well, this little tiny graph, yeah, but we know that it continues to go to the right and down forever. So at some point, it's going to get down here to quadrant 4. So it does not only exist in quadrant 1. So that is false. That's why we have a red circle right here. The domain is x is greater than or equal to -2. Well, the domain, you got to think about your most important point, your HK value. The domain is 2. I mean, yeah, your input, the x value is 2, and that's where you get your domain from. So at the x value of 2, does it exist to the left? To the left of the x value of 2, which would be x is less than or equal to 2, or to the right of 2, which is x is greater than or equal to 2. It's obviously to the right of 2. So the domain is x is greater than or equal to 2, not -2. All right, so this messes it up. That makes this statement false. Okay, if that would have said a +2, then yes, we would have been that would have been correct. Over here, we have the range is y is less than or equal to 8. Well, yeah, you're way up here at the y value of 8. Remember, the k value is 8, And does it exist above 8, which would be y is greater than or equal to 8, or below 8, which is y is less than or equal to 8? Obviously, less than or equal to is the correct answer. That's why that is green right here. Last but not least, the transformation from the original parent graph, from this yellow one to this new one, consists of a reflection over the x-axis. Yes, we said that the negative sign is a reflection over the x-axis. And then it shifts 2 to the left. Does it shift 2 to the left? And 3 up? What? That's way off. It shifts 2 to the right and 8 up. Okay, so that's definitely wrong. So the only one that's true is this one, the range. Everything else is false. There's something wrong with those statements. Moving on. It appears we are moving away from square root graphs. I don't know, we might revisit them, but right now we are looking at radicals, at simplifying square roots. All right, so first thing, let's read through this. A square root is the same as the power of 1/2. That is absolutely true. We should all know this, that a square root is really the same thing as the power of 1/2. Okay, or likewise, you could say that a third root is equal to the power of 1/3, or a fourth root is equal to the power of 1/4, and so on and so on. So a square root is the same as the power of 1/2. That's absolutely true. That's why there's a green circle right there. This one right here, it reads the square root of x to the 25th equals 5. A lot of people think, oh, the square root of 25 is 5, so this must be correct. Wrong, right? Why? Okay, we need to understand or remember this, that the square root is a power of 1/2. So ultimately, we want a power to be divisible by 2, because a power to a power you multiply. So we want a power to be divisible by 2. Now 25 is not nicely divisible by 2. So 24 would be great. So the first thing to do when simplifying the square root of x to the 25th, first thing to do would be to rewrite it as the square root of x to the 24th times one more x. That would get you back to the x to the 25th. And of course we split the root, and now we could think of the square root of x to the 24th. We could think of that as the power of 1/2 with the x to the 24th in there. And of course we still have the outside square root of x. And right here, a power to a power multiply, so 24 times half is 12. So your answer will be x to the 12th, and the square root of x just stays. So the correct answer to the square root of x to the 25th is x to the 12th times the square root of x, not x to the 5th. So that's definitely wrong, okay? Let's move on over here. The square root of x to the 36th, we just did a problem like this. The square root is the power of 1/2, so we want something divisible by 2. Is 36 divisible by 2? Heck yeah. So you already know the answer is x to the 18th. This is true, because all you have to do is think of it as the power of 1/2. And you got x to the 36, and of course a power to a power you multiply. So 36 times 1/2 is that 18 that we have there. So this is true. That's why there's a green dot right there. Last but not least, we have the square root of 9x to the 9th. The answer is not 3x to the 3rd. That's totally incorrect. Let's actually work through this. First of all, because there's multiplication between the 9 and the x to the 9th, you could split the root, square root of 9, square root of x to the 9th. Now the square root of 9, yeah, that's 3, but the square root of x to the 9th, we know that the square root is the power of 1/2. So I would like this to be an even number, so it'll be divisible by 2, right? Multiplying it by half. So I want this to be an 8. So I'm going to rewrite this. I'm going to rewrite this as the square root of x to the 8th times one more x. Again, x to the 8th times x gives you that x to the 9th that you had, and I already split the square root to each of those. And the square root of x to the 8th, that's really the power of 1/2 on x to the 8th. And of course you bring down that square root of x, and what is x to the 8th to the power of 1/2? Multiply those powers. 8 times half is 4, so you have x to the 4th square root of x. So what we have here, ladies and gentlemen, is a 3 right in front of that x to the 4th square root of x. And that's exactly what we have over here, 3x to the 4th square root of x, which means that this is a true statement as well. Okay, I hope this makes sense. Let's move on. So we need to be comfortable with simplifying square roots by this time. So it's simple as this. If you have nothing but multiplication inside your root, you could split all your terms and put a square root on each of them. That's what I'm going to do. I'm going to put the square root on the 25. I'm going to put the square root on the x to the 4th. I'm going to put the square root on the y to the 16th and the square root on the z. Okay, so I could do the square root of 25. That gives me the nice, beautiful answer 5, no more root. I could do the square root of x to the 4th. Remember, a square root is really the power of 1/2. And what's in there, it's an x to the 4th. So a power to a power, you multiply. 4 times half is 2. So you really end up with x squared. Half of 4 is 2. And same deal over here, y to the 16th to the power of 1/2 instead of the square root of y to the 16th. That will be power to a power multiply. 16 times half is 8, so you have y to the 8th. And the square root of z, you can't really do anything with that, just bring it down, the square root of z. So let's not forget about this 5. Let's bring down that 5. And here is technically my answer, 5x squared y to the 8th square root of z. 5x squared y, nope, 5x, nope. 5x squared y to the 8th, oh man, all we needed was a square root of z right there, and that would have been it. And what the heck, this is the same exact answer. That's, well, obviously the answer is none of these, because the correct answer is not there, even though I messed up on those options. I'll change that later. Moving on. So again, we're going to show our work here. The square root, we're going to split that to the 16 and then the square root on the x to the 16th as well. So we have the square root of 16, and we also have the square root of x to the 16th. Now remember, the first one, super easy. This guy right here, the square root of 16, that's just 4. That's going to be part of our answer. As we could see, all of these answers have a 4 out there, so that didn't really help us that much. And let's focus in on the square root of x to the 16th. We're going to rewrite the square root as the power of 1/2, and on the inside we have x to the 16th. And of course, a power to a power you multiply. What is 16 times half? What's half of 16? X to the 8th. So x to the 8th is our answer right there with the 4. There's our answer, 4x to the 8th. And as you could see, this one, whoops, this one right here is the correct answer. Finally, we get to a cube root instead of a square root. Okay, so this is a little bit more fun, right? What we have here is the cube root of negative 27a to the 6th. A lot of people are going to think that an I is involved because of this negative. That's incorrect. That's only on square root functions. Because think about it, the square root of negative 4, what times itself will give you a negative 4, just doesn't work, right? 2 times 2 is 4, negative 2 times negative 2 is also 4. So it's only on square roots where a negative will produce an imaginary value. I mean, think about this. You could actually do the cube root of negative 8. What number times itself 3 times will give you a negative 8? That'll be a negative 2 times negative 2 times negative 2. That will give you a negative 8. So it is okay, totally fine to have negatives inside cube root functions, okay? Anyway, let's get this out of the way and start simplifying this guy. So once again, we do have negative 27 times a to the 6th. I'm going to split that cubed root. Here is the cube root of negative 27, and here is the cube root of a to the 6th. Now, we should all know that this guy works out beautifully. What number times itself 3 times will give you a negative 27? That would be a negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. So the answer here is just a nice, beautiful negative 3, right? That's the answer for that one. Now let's do this other one. Again, remember, a cube root function, or a cube root, is the same thing as a power of 1/3, okay? And we still have the a to the 6th on the inside. And now we know that a power to a power we multiply. 6 times 1/3 is 2, right? 6 times 1/3, that would be like 6 times 1 is 6. The invisible 1 times 3 is 3. 6 divided by 3 is 2. So we really have 3a to the 2nd power. So this is our answer, negative 3a to the second power, which will be none of these. Okay. This one looked like it might be, but it's missing that minus sign, so there is no correct answer there. Alrighty. This one's too easy, right? Square root is the power of 1/2. So you really have the power of 1/2 with the x to the 36th in there. And again, a power to a power, multiply. Your answer is x to the 18th, because 36 divided by 2 is 18. And obviously, none of those are correct. That was quick. Let's move on. All right, here we go. Again, if you only have multiplication between all your terms, 12 times x to the 36 times y to the 9th times z to the 25th, you are able to split this square root to each of those terms. Okay, so let's do that. So this is kind of like doing 4 simple problems at the same time, right? Let's begin with the square root of 12. 12 is not a perfect square number. We want it to be a perfect square number. Let's rewrite it with multiplication to get a perfect square number. 2 times 6 will not cut it. You want a 4 that's a perfect square number times 3. That way, when you split the root, you'll at least get the square root of 4, which is a nice, beautiful 2, no more square root. And the square root of 3, it'll just stay. So far, this first part gave us this first part of our answer. Let's move on to this next part. I am going to do this one over here. The square root is really the power of 1/2. And on the inside, we have the x to the 36th power. And once again, power to a power, multiply, and you will get x to the 18th. Okay. What about the next one, the square root of y to the 9th? Like always, we want to remember that a square root is really the power of 1/2. And ultimately, we want an even number right here. Like right here, 36, that was beautiful because 36 divided by 2 is 18, right? 36 times half is the same thing as 36 divided by 2. So we want a number that's divisible by 2. Right here, 9 is not divisible by 2. I mean, it doesn't work out nicely. So I need to first begin by rewriting this as the square root of y to the 8th times 1 more y, right? Obviously, y to the 8th times 1 more y will get us back to that original y to the 9th. And now we could, right here, with this guy, the square root of y to the 8th, we could rewrite that as a power of 1/2, put the y to the 8th right in there, and that will give us y to the 4th, because power to a power multiply, 8 times half is 4. Let's not forget about the square root of y to the 1. I'm just going to put the square root of y, right? And last but not least, we need to do the same for that one. So we have the square root of z to the 25th. Again, we want something that's divisible by 2. So I'm going to rewrite it as z to the 24th times 1 more z, right? And when I split that root, I'll be able to do half of 24, right? So the z to the 24th is right here. 24 times half is 12. So I will get z to the 12th. And this over here, you can't do anything so with it, so I'm just going to bring it down times the square root of z, okay? So let's look at all of our answers here. I'm going to highlight them. We have 2 square root of 3, we have x to the 18th, we have y to the 4th, we have the square root of y, we have z to the 12th, and the square root of z. So what we need to do is take all of the values that are not in square roots and write them in order out in front, and take all the values that are in square roots and put them all in one square root, okay, in order, right? So let's begin with the values that are out in the front. We have a 2, we have x to the 18th, and we have a y to the 4th, and a z to the 12th. Again, I'm ignoring all the square roots for now. So here's our answer so far. 2, x to the 18th, y to the 4th, z to the 12th. And now we're going to look at our square roots, right? And I'm going to write one giant square root right here. And I'm going to put the 3 right in there, okay, 3 right in there. And then I'm going to put the y right in there, so y. And then I'm going to put the z right in there, z. And it's that simple, guys. I know it sounds complicated, it looks like a lot of work, but it's really not that bad. So which one is it? We have 2x to the 18th, y to the 4th, z to the 12th, and 3yz. This is it right here. Alrighty, guys. I hope you guys study this quiz and get an A. See you in class.